Welcome to our webinar entitled Exploiting the Internet of Things with SAP Fiori. This is the third in a series of 6 short webinars in which we'll be looking at Fiori-based solutions to business challenges. My name is Henry Blythe and I'm the CEO at Arch. For those of you who don't know us, Arch is a software company specializing in SAP user experience and process integration. I'm delighted to be joined today by Chris Scott, our Director of Business Development, and by Mohammed Jafrali, who is a solution architect here at Arch. We're recording today's session, which should last around 30 minutes. If you have any questions, please use the Q&A section on your screen, and we will address them at the end of the session. So with that, please go ahead, Chris.
Thank you very much, Henry. We're going to keep the agenda really simple today. We're going to kick off by discussing some of the challenges we see for customers trying to build IoT-based solutions. Then I'll introduce our approach and how we address those challenges. And finally, we'll show you a fantastic demonstration of IoT data with SAP Fiori. We live in a rapidly changing world, a world of machine learning, of predictive analysis. Our world is getting more and more connected. Connected goods, connected assets, connected fleet, and connected people. Data is collected in more ways, more than ever before. The combination of IoT and Fiori provides the opportunity for new business processes and new business insights, leading to new business advantages. IoT is of course a huge topic, so let me start by containing the conversation to what we can achieve with the combination of sensors and big data. So innovations in sensor technology, along with the advent of big data, particularly big data in the cloud, means that we can collect billions of records from all kinds of information from all kinds of sources. Having collected the data, now, of course, we can use it to drive reports, and we can deliver amazing analytics apps and dashboards to keep users more informed than ever before, or feed the data into predictive analysis algorithms. But our first challenge is how to hook this data into business processes in real time. How do we do that when we're collecting millions or billions of data records? When does it make sense to trigger a back-end process, and how can we achieve this? This is a challenge recognized by SAP, who just last week launched the SAP Leonardo IoT Bridge, which is a new component of SAP Leonardo designed to make that easier. And we've actually not got our hands on that just yet, but we're looking forwards with great interest to see just what it can do. I started by saying that we realize some of the benefits of IoT and Fiori through new business processes, new ways of doing things. What do I mean by that? In the previous webinar, I talked about the challenge of moving away from SAP standard processes, and really that's the kind of challenge organizations need to accept in order to reap some of the rewards. Let me give you some examples. Let's consider physical inventory, stock counting. In SAP, there is a well-defined, prescribed process of creating the counting sheets, performing the count, and then posting the differences, or alternatively cycle counting. But in the IoT world, the stock can count itself. And indeed, it can count itself not just in the warehouse, but in transit or in customer consignment. So in that scenario, everything we know about physical inventory processing in SAP is outdated. Everything. Let's consider another warehouse task, a put away. In the traditional SAP process, the system will suggest a bin on a transfer order, and then the operative puts the stock away and confirms that transfer order so that the system knows exactly where the stock is. But in the IoT world, we can track the stock by location, so we don't want to have to confirm transfer orders or scan stock manually in and out of locations. In fact, all WM updates could be completely automatic based on the physical location of the stock. So we can entirely remove the need for the user to touch SAP other than to be told what to do. And finally, let's consider backorder processing, where stock in limited supply is effectively shifted from one sales order to another. This typically happens in a periodic job before delivery planning. But in the IoT world, we can track stock in shipments and we can track the physical location of those shipments. So we could reroute deliveries to cater for rush orders, performing backorder rescheduling, but on deliveries, not on sales orders. And in the future, perhaps all orders are rush orders. So this would be a totally new way of working, and SAP just doesn't work like that. So what I'm saying here is that some traditionally best practice SAP processes are not necessarily fit for purpose in this new IoT world. So how do we integrate IoT data to back-end processes when the process is brand new? How do we define those new processes while still getting the best from the SAP system? That's our second challenge. So let's move on to our approach. Sensor and emerging IoT technologies provide the ability to connect our goods, assets, equipment, fleet, environment, and people via the internet. And we underpin this by providing the business process integration from those connected things and providing the ability for you to define new business processes. But before I talk about our software, I want to talk through some examples of such connected processes. We start off with connected goods. IoT lets us track, for example, the temperature of goods in transit or at customer. So consider fresh produce or medical supplies. When the temperature of the package is too high, we can trigger real-time notifications or take other action, including cancellation of quality assurance or even a product recall. The benefit is in guaranteed quality and reduction of risk. Connected equipment. IoT lets us monitor our equipment. Let's consider safety equipment like fire extinguishers. We can monitor the location and the performance of the equipment. Is the extinguisher there? Is it full? We can trigger replacements or servicing automatically when the equipment is used or removed. The benefit is the guaranteed availability of working safety equipment. Connected fleet. IoT lets us track our vehicles in many different ways. We can monitor, for example, the movement, the location, the capacity of each vehicle. Based on rush orders or emergency requests, we could reroute vehicles. The benefit is a huge improvement of response to urgent needs. Connected environment. IoT lets us track environmental factors. Let us consider the monitoring of river water levels near floodplains or background radiation near power stations. Based on real-time data, we can trigger news alerts or evacuations in real time. The impact is a faster and more effective emergency response. And finally, connected people. IoT lets us track people. Let us consider the movement of people near dangerous zones like power stations and construction sites. Based on their physical location, we can trigger notifications, trigger alarms, or send in security teams, all in real time. The benefit of this is real-time safety monitoring, assessment, and accident prevention. So I haven't chosen these 5 examples by accident. There's, of course, a common thread running through them. There's benefits of safety, of risk reduction, and even saving lives. So in a sense, that's what all this is about. So what do? We add the business process integration from IoT data. That includes managing real-time triggers for back-end processes, the process definition, new user interactions through SAP Fiori, and integration with the SAP back-end data structures. So how does that work? So first of all, data is collected using a sensor and pushed to the IoT server on the SAP Cloud Platform. We can then provide a rules engine to run business rules to determine when to trigger the processes. Triggers are sent to Stalo, which is our platform to manage Fiori-based SAP processes. This is installed on your SAP system. Stalo provides all the functionality to build and manage custom processes and integrate them with your own SAP data, all inside your own SAP system. Users interact with the Stalo process using a Fiori app, deployed either on-premise or back in the SAP cloud. And in fact, we can build the Fiori app to consume IoT data directly to show real-time data to users. Stalo provides us with the ability to generate the Fiori apps, but also to model new business processes integrated with both IoT data and back-end SAP data. Put simply, Stalo allows us to consume IoT through SAP Fiori and to exploit IoT in the SAP ERP system. So we're going to walk through a demo in a bit more detail, and it's in fact the connected people example I introduced earlier, where we track employees in and around danger zones. So now I'm going to hand over to Jaffa, who will take us through this demonstration. Jaffa.
Thanks, Chris. All right, so before we dive into the actual demo, I'd like to give you a quick overview of how we came about building this demo. So a few months ago, we had a request come in from SAP in the Middle East for building a little POC for one of their public sector clients who runs a massive oil refinery. So the idea was basically to an ability to track field workers who tend to work in danger zones. So basically, in this instance, we are going to be focusing on an oil refinery. So people, the field workers themselves, are going to be out and about. And within this oil refinery, there is designated zones which the administrator would have defined. So basically, the idea is to track and monitor the movements of these field workers. So basically, the three core objectives that we're going to cover in this demo. The idea is, objective one is define a geofence, basically defining a perimeter around this oil refinery. The second objective is to plot and track the field workers. So basically, the field workers are going to be wearing RFID tags, which is going to be pushing their geolocation data to the IoT server. And the third objective is to trigger processes, as Chris said. So in this instance, we are going to kick off email notification to administrator whenever a breach happens in one of the zones that we're going to define shortly. So the idea is we're going to define the geofence, we're going to track people, and we're also going to trigger a process. In this instance, it's going to be an email notification. So what we've got in front of us on screen is basically a Fiori app built using the Stalo technology that consumes IoT data, which is basically fed from the RFID tags which the field workers are going to be wearing. And what we're going to do is we're going to consume the IoT data from the server. We're going to analyze the data. We're going to plot physical geolocation markers based upon the field workers' latitude and longitude data that we've got. And we're going to analyze that against the confined space we're going to define, which is basically a confined boundary. And if the field worker is spotted entering or breaching a specific boundary, then what we're going to do is we're going to fire off an email notification. So broadly speaking, we've got two sort of different operations that we would be doing. The first operation is basically administrative operation, where the administrator is going to go in and define the physical zones within the over the map. So we're going to do that now. And the second operation is basically the monitoring operation, where we will be monitoring the field workers' individual location And basically based upon that, we're going to analyze the data against the confined space and trigger off a notification. So stage one, what we're going to do is we're going to do the administrative activity. So we're going to define a danger zone. So in this instance, what we've got is we've got a number of zones that we could define. In this demo, we're going to cover off danger zone and warning zone. So I'm just going to physically draw a danger zone over this area, over the geomap. So what we've got is we've got a terrain map in the background, which is a real map of Saudi Aramco's oil refinery. So that's our danger zone defined. We are also going to define a warning zone. So what we have done here is we have marked these two different areas using the terrain map. We have marked a danger zone and we have marked a warning zone. Now the administrative activity is done. Now we're going to move on to the actual monitoring activity. We're going to physically track and trace the field workers' movement around the oil refinery site. Okay. So in order to do that, obviously we don't have data coming in real time. So what we have done is we have captured some data and we have stored them on the IOT server. So I'm just going to run a simulation that's basically going to simulate as if people or the field workers were out and about moving around the oil refinery. So before we do that, I would like to draw your attention towards the zone analysis area. So in this section, what we've got is we've got physical counters, which is going to go up and down based upon the number of field workers who are going to be spotted entering the danger zone and warning zone. In this instance, in this example, everything else is considered safe. It's not been marked. So we've got a marked danger zone and we've got a marked warning zone, and everything else is considered safe zone. So just keep an eye on these counters. It's going to move up and down based upon how the field workers move around. I'm also going to turn on my email notification, and I'm just going to hit run simulation. Now we could see what we've got is we've got physical geolocation markers being plotted on top of the map, and these markers basically are going to change color based upon how and where they are spotted at a particular point of time. So in this instance, we got two field workers moving in and about, and there's one who's been spotted in a warning zone. He's turned amber. There's one in safe. Now the other one has moved into a danger zone. So as I said, what the process that we're going to trigger in the background is basically, in the backend, what we have done is we have sent, based upon the defined logic. In this instance, what we have said is if we spot a field worker in one of these confined zones, which might be a danger zone or warning zone, we have to trigger an email and send the email off to administrative manager, who's going to basically physically monitor which employee is being spotted where and when. I've got a flurry of emails that's arrived. I'm just going to show you an example of the email that's come in. So we've got a perimeter breach email. We've got a number of dynamic parameters that we have embedded in the email itself. So we've got a danger alert that basically saying there's an employee being spotted in a danger zone. We've got some metadata around the employee. Who was it? What sort of what was his RFID tag ID, and when was his physical breach happened? And we've also got a little map with a physical pointer, which basically says where he was last spotted. We've also got another email which is basically warning alert. As you would notice that we've got dynamic parameters that's been filled in. This email, beautiful email that we've got here, is basically built using our other product, which is Flow, and which gives you this ability to define dynamic emails based upon the data that's coming from the front-end application. So what we have done is we have used the Sailor technology here to push data to the back-end. We have used the other product that's Flow, which builds up the email with the metadata that's come around from the application and has dispatched the email to the administrative contact. And in this instance, I've got the emails. So in terms of the process triggering, we've covered that. So just before we wrap up, I would also like to draw your attention towards another nifty feature that we have got here. What we try and manage here is to pull the employee's HR information from SAP HCM based upon the employee's personal ID, which is linked to the RFID tag. So once we hover over and click on a particular employee, we get a pop-up with the employee's metadata all pulled in real time from the backend using the Stalo technology that we've got here. So in here we've got the name, department, RFID tag, and also the latitude and longitude position of where the employee was last spotted. Back to you, Henry.
That's fantastic. Thank you very much, Jaffa. Great. I think we now have time for one or two questions, but obviously I'll follow up afterwards if there are any questions we don't have time for today. Just got a few minutes. So if you've got any questions, please put them into the Q&A, and Jaffa, myself, or Chris will have a go at answering them. Okay, I've got one here. So is Stalo just for IoT processes? So I think I can answer that one. Stalo is designed for any SAP Fiori process. So it's a framework for getting more done with SAP Fiori. Now, the ability to consume IoT data from SAP Leonardo, that's just a fantastic way to use Stalo, but it's not the only way. So the answer to that question is no, it's not just for IoT processes. Could be for anything. So yeah, any SAP process. In fact, we tend to, our work so far has been doing quite complex things like complex good receipting and so on. But yeah, the IoT is a new thing, and we found it works really well for IoT. Okay, another one. Yeah, I should have said this actually. Is the demo available? Absolutely it is. We will send out a link to the video demo on YouTube as a follow-up. Yeah, absolutely, the demo will be available. We've got a little sort of 2-minute version of what you've just seen as a YouTube video. Okay, so thank you everybody who joined us here today. We will follow up with a link to the recording of the whole session, and we'll also send you an invitation to the next webinar in the series, which is entitled How Using Personas Helped Amy Design Better Fiori Apps. You can see that one there. So we're 4 webinars through our 6-webinar series. So during that session, we'll share more real use cases. You can find out more about Stalo on our website, I should say. That's arch-global.com. But in the meantime, I hope you can join us again for the next webinar in our series. But thank you for your time today, and goodbye. Thank you.